Today in pre-cal we learned about how to find the arc length and we also learned how to find the area of a sector. To begin with arc length, the formula is S equals R times theta, where S stands for arc length, R stands for radius, and theta stands for the angle in radians. It is important that this is in radians. If you don't change it from degrees to radians, it will be wrong. The concept we're talking about here is if I talk about an angle, and let me make a little bit bigger one just for the sake of argument. So if I start here at 0 and I let my angle go all the way to here, my angle is this measure here, but if I have a circle that goes from here to here, let's pretend it's a perfect circle, that would be my S, my arc length. And I want to know how long is this piece around the circle. I will use the radius that goes out from the center times the angle in radians, and that will give me this measure. Let's do an example of that. Number 1. R is equal to 4 inches, so that's our radius, and our theta is 240 degrees. We need to change our theta over to radians, so we're going to do 240, and then we're going to multiply by pi over 180. Remember we learned yesterday that that was the factor to change it over. So, to do that, we're going to do 240 pi over 180 and reduce. 6 goes into both of those, so we're going to end up with 4 pi over 3. And that was just to find it into radians. Now we can plug it into the formula. So our arc length S is 4 pi over 3 times our R. So theta times R. 4 times 4 is 16. So this is 16 pi over 3. And that is the length of this arc. Now I could put that in my calculator and get a decimal, and that answer would be acceptable as well. The second thing we need to learn about today is the area of a sector. And that concept is basically if I take and I make an angle again, and I still do my arc length, which is this distance here, but then I shade it in. Okay, and I want to know the area of this shaded region. I can use this formula, A equals 1/2 theta R squared. Again, my theta needs to be in radians. But I can use that right there to get an answer, that formula, to figure out how much area this is here. For example number 2, the sprinkler, okay, think of a sprinkler that ticks around, waters the yard. I want to know how much of the yard it waters. So the distance it can cover is 70 feet, and it rotates 120 degrees. Okay, and I want to find the area that's being watered. I'm going to use the formula. I'm going to plug in and change 120 degrees to radians by multiplying by pi over 180. If I reduce that fraction, I'm going to get 2 pi over 3. And so to find the area, I'm going to do 1/2 times 2 pi over 3 times my radius, which is 70 squared. Okay, now I can either do that without the calculator by canceling some things out. 70 squared is 4,900 times pi on the top, all over 3. And I could leave my answer like that, or I could put it in my calculator and get 531.268 feet squared. And it is always going to be square units on area. On length up here, it would have been just feet, right? Or inches, I'm sorry, because we're talking about inches. So this sprinkler covers about 5,000 square feet, which is pretty impressive. That was all we did for today. The assignment is page 292, and it's numbers 87 to 94. Let me know if you have questions.